All right, good afternoon, everyone. Welcome back. So, I appreciate everyone joining here. I'm also joined by a very esteemed um, group of people. Our focus today is going to be talking about ADAS and autonomy, something which I'm sure many of us have read a lot about in the press. ADAS and also autonomy are definitely one of the poster childs of AI implementation at the edge, and I think in many ways will help define how that technology permeates our day-to-day life in other markets as well. So when we chose the topic, obviously the idea was to pull together a group of industry experts who spend a lot of time thinking about this problem and working it, but also use their experience to try and look into the future and say, if if autonomy is going to happen this way, what else can we learn from the AI experience as it starts permeating our day-to-day life? But before we jump in, would like the group to introduce themselves one by one, starting with Sham.
All right, good afternoon. I'm Sham Sundar. I've been at GM. I joined about 2 months ago. I'm responsible for hardware product management at GM. But prior to that, I've pretty much been a San Diegan for a long time. Qualcomm, NVIDIA, semiconductor software, and then the last few years at the EV startups, Faraday Future and Fisker.
Good afternoon, and for those who are awake, thank you for coming after a big lunch break here. My name is Suman Narayan. I manage the products for Allegro Microsystems. I want to thank Samir and Faisal for inviting me here. I'm based in Richardson, Texas. Our company is based in Manchester, New Hampshire. We manage and develop products primarily for sensors and power products. We help both the steering and braking systems for ADAS. So if you see the sensors and if you're turning a wheel in a car, it probably has one of our sensors in there.
Good afternoon. My name is Rajat Sagar. I work for Qualcomm in the Automotive group, and I lead the autonomous driving systems products. But in autonomous driving systems, what we do is Qualcomm, we develop the compute SoCs, the chips which are the heart of running the compute software, AI, and everything that autonomous driving needs. But in my group, we also develop the software, the AI software, and the full stack for autonomy. And that's pretty exciting because we see that this technology is not just there for comfort and making long drives easy, but it essentially saves lives, and we are very excited about that. Thank you.
Good afternoon. My name is Saurabh Bhatnagar, and I am with NEO. I deal with all things business in our North America operations. NEO is a car company. We build cars, okay, and our cars are all smart and all electric. So that's what we do. Uh, we pride ourselves on being very technologically forward. So we invest a lot in R&D, and we try to make sure that our users are seeing new exciting features from us all the time. The company is about 10 years old, and I've had the privilege of being with the company for about 9 of those 10 years. So a very exciting journey. And last thing I'd say is we are operating in multiple important global markets, but we are not in the US yet. So even if you're not familiar with our vehicle portfolios, you might have seen some of our cool tech. We are known for swappable batteries. So we are the company that established that technology. Uh, we have also got some very cool videos going that people know us for around new ways of dampening roughness on rides and so forth. So champagne flutes on a car and so forth. So, I encourage you to take a look at those if you haven't done so yet.
Excellent. Thank you. So as you can see, we have a 50% mix. We have 50% auto car manufacturers, and we have 50% vendors. So this promises to be an exciting discussion. So let's start with the biggest question in front of us, right? ADAS, so driver assist systems, have been deployed in vehicles for over a decade now. Different degrees, anything from lane change assist to pedestrian detect. As we continue progressing on that curve, the question on autonomy has been quote unquote, plaguing us for a very long time. There were some predictions made, I don't know, 5, 7 years back that by 2024, 2022, whatever, there would be a lot of autonomous vehicles on the road. I drove back from lunch, did not see many on the way. So the path to autonomy, from your perspective, is it revolutionary in terms of technology or is it evolution? Let's start with that. And if you don't mind, sort of, let's start from an automaker's perspective.
Sure thing. And this question, this consideration is kind of in the qubit category for me. So it depends. It can be one or the other or both, and it depends on your sort of vantage point. I will say that for an OEM, when you consider the path, you need to think about both the technology as well as the commercialization and the commercial aspects of it. And the two sort of interact, and the stress is really put on the arc to feature delivery. So, if you take that lens for us at NEO, it's certainly an evolution. And we like that, and it works for us because the arc to the end, the pot at the end of the rainbow for a revolution, a quick snap, is pretty long. And we have people that have bought our vehicles, they are looking for new features, new functionality. The evolutionary path actually gives our users a lot of delightful, I'll call them detours on the path to the final goal of autonomy. So I'll give you a quick example. I was talking about this, battery swapping technology that we have. It's pretty cool. Essentially, a car pulls up, it pairs with what we call a swapping station. There's a robotic arm that sort of takes the installed battery out of the car, puts a fully charged battery into the car, and within 3 minutes, without the driver, the user even getting outside the car, you are fully recharged. Okay, so this is a cool bit of technology. On the other hand, NEO has been developing and deploying various levels of increasing AD in our cars. But because we have been incrementing, now we have an amazing use case. Now we are able to offer something that we call power swap on pilot, which means I set a route and the car knows where I'm going, also knows the state of charge for the battery, and on its own, autonomously, not only does it drive, but it can navigate to the power swap station, autonomously swap the battery, autonomously move on with nothing happening. So this is an example of a nice detour on the path. So, for us, certainly evolution is the way we see it, and evolution provides constant incremental value to our users.
Rajat, you want to continue?
So, see, at Qualcomm, we develop technology. We are a technology supplier, system supplier. And especially in my group, we are doing both. We are doing the silicon part of it and the software part of it. The way I see it is actually not evolution, rather, I see it more of a revolution. And the reason is in few, I'll give few examples. So, first of all, the level 4 autonomy problem is linked to increasing the reliability of the automated driving car on the road. I think there are a few benchmarks, but the popular one is the mean time between failures, MTBF. How do you increase the MTBF to a level that a human can drive, right? And when you think about the problem from that perspective and compare the MTBFs and the failure rates today, which are abysmally low. So you have to think about, okay, what do we have to do different in technology to solve that problem? So few changes which are happening to solve this problem. First of all, the problem to solve the reliability is moving the development from a traditional point solving methodology, which was there in ADAS. ADAS example is that the problem was, let's solve for automatic emergency braking. But when you have to solve for autonomy, level 4 autonomy, AEB is just one of the function. You have to solve for all the corner cases. The corner cases in highways, in splits, going to urbans where lanes are visible, not visible, map is available, not available. So the development has to shift from a point solving mechanism to a data-driven development, which is continuously learning and evolving. This necessitates the need for having AI-based models, which are shift from a traditional modular-based systems to the new end-to-end AI-based systems, which can then enable this data development models, and that's what we are developing to solve this problem. And when you to do this, then we look at how do we plan the compute and the underlying SoCs to solve that. And unfortunately, or fortunately rather, uh, uh, the compute is still scaling very, very well. It's not a solved problem because at the edge, compute is still bound by the thermals and the power envelope and the form factors of what is there in the car. So we have to think about new ways of newer architectures, heterogeneous architectures, low power architectures. How do we bring these advanced AI models, this high compute, low level processing on the edge? All this also has to be done with software in mind and functional safety and safety architectures in mind. How do we ensure that when failures do happen, there is redundancy in place and fail operational architectures in place? So these changes, in my perspective, are more revolutionary. But I also feel that while the level 4 autonomy development is in the works, and at some point I do believe that it will start happening, all these technologies are also percolating downwards in level 2. So as a result, and that's kind of our focus, that while we are focused on pushing the technology envelope to solve the level 4 problem, how do we take these elements and mass deploy at the level 2, which is available in cars today?
Yeah, I mean, I think I would agree with what Rajat said here, just the mean time between failures. But let me start by, my vantage point is on the sensing side. So if you look at it, we're like the eyes and ears of, the car. So we have to do two things really well. One is we have to steer and we have to brake for autonomous driving. But as the architectures are evolving, we see that, at least from an OEM perspective, a lot of the efforts are going into the evolution of the steering and braking systems. You might be familiar with EPS. How many of you own an Xbox here? Those who are awake. Okay, a few of you own the Xbox. So you see a lot of the steering systems are moving to steer by wire. The column EPS, the standard power steering system, is actually going away, in a lot of these cars. The second thing that's happening is that the braking systems are moving from hydraulic brakes, to mechanical brakes. The EMB stuff is happening. And there's a transformation that'll happen over time where you've seen the crab walk in some cars. Some of you guys have seen those videos of crab walk. So what it is that if you start to converge the EPS EMB systems all into the 4 different wheels, then we run into problems of what Rajat just talked about, which is really how much redundancy do you need and how do you make these cars fault operational? It's basically, how do you make it operational even if some devices fail? I think that's the problem that mostly is a revolutionary problem in semiconductors, because how much redundancy do you really need? Do you need to have 6 times the number of chips that you already have in a small constrained area on the wheels or not? So that's the revolutionary part. But there's a lot of evolution that's happening in both in braking and steering, which are driving that. So if those are solved, I think then you can get to the software problems that Saurabh talked about on the Neo side as well. Thanks.
Yeah, from an automaker perspective, I would say it is evolutionary, because autonomy is about delivering better user experience to our users. I mean, being able to take more decisions about driving off their hands and freeing them up. And autonomy is also about a series of maybe thousands, maybe even millions of small decisions and actions to be taken to be able to drive the vehicle in a real life scenario. So I do see that necessarily that is evolutionary. You're going to have to solve one problem at a time and continue to learn from it. And it is a huge learning exercise, not only for the models and the algorithms, but also for the engineers and the automakers themselves. So yeah, I don't see that as revolutionary. It's really evolutionary, and we could say, hey, we'll solve this in 1 year or 10 years or 15 years. We could be all right. So it's hard to say when it'll be completely done, and it's a revolutionary step forward.
Excellent. So, just in case people were still coming back from lunch, we have a panel which is split right in the middle. The silicon vendor community is like, let's have a revolution, let's bring new technology. As expected, the automakers are a little bit more conservative. So let's keep going. This is good. So now, if you think about the ecosystem, right? Automotive has for years had a very classic ecosystem where you have silicon vendors, you have tier ones, you have auto manufacturers, and then you have the customer. As we evolve on technology, your opinion on how this ecosystem evolves, if it does, what roles may switch, and how do you see that playing out? And Sham, maybe you start.
Well, I mean, like I said, I've been in San Diego for a long time. I started in the phones world, and phones made a big leap in 2007. You know what event I'm talking about. And the phones of 2006 were, I don't even know, they were primitive compared to what we have today. I believe we are in the early stages of that revolution in automotive. As advanced as we think the semiconductors and everything is, there's a lot more that needs to happen to make our cars more intelligent and more effective, really becoming, there's all these cliches, right? Smart device on wheels, data center on wheels, you name it. We are at the early stages of that, and absolutely the compute advances that have happened so far have enabled very big leaps in technology in vehicles, but it is necessarily a slow progress because of the safety aspect. But I think the future is uh, very significant, very bright. There's a lot that needs to happen to make our vehicles extremely smart. If you think your phone is smart today, a car can become 100x smarter just because of the sensors and the environments it operates in. We're at the beginning, and I'm very excited to see that again, the evolution of this and building very, very smart vehicles.
For us, just going back on the discussion around the ecosystem. So I think most of you know that the silicon vendor today sells a lot of the chips to the, and silicon can be three things, right? And just to oversimplify silicon, it's really compute, it's memory, and it's sensing. So if you just kind of break it down into three basic elements, I'll let Rajat talk about the compute side, and I'll just focus on the sensing side. So today we sell our sensors to tier ones. Tier ones sell it to the OEMs. And what has changed in that ecosystem for us is we are getting a lot more direct requirements. Just like Shyam said, from a software perspective, I think the OEMs have a view and a vision of what the software needs to be in the future. So we are getting a lot of direct requirements from the OEMs on what the chip needs to be or needs to do in the system so that it makes their software lives a little bit easier. So there is a big shift in the ecosystem. Instead of having if you watch the movie Lost in Translation, between a tier one to the semiconductor vendor, is a lot of bypass now where the OEMs are directly working with the silicon vendors, not just on the requirements, but also the needs for customization of their chips so that it makes their software a little easier as well.
Yeah, no, I agree with both Sham and Suman, and I'll build on that. I in my mind, we start from what's actually. I think Sham said it, that it's a data center on wheels. It's new experiences. The focus is shifted on software, and when we look at it from a technology standpoint, what we see is that go back 5 years, the traditional sourcing was done where a chip vendor will produce a chip, somebody will write a software, and it will go into a car. The box will be sold, and that's it. The car is sold. That's what the user experiences. Now, and as we shift into the future, all their focus is about how do we keep the software as a living entity in the car with more applications and features and enhancements going over the period of ownership of the car, right? And with EVs, I believe the period of ownership also will get elongated. So what this means is that from a technology standpoint, the chip is just one of the enabler, but along with chip, there is a ton of software that has to be also enabled and re-architected to gear for this continuously evolving platform that the OEMs can work on. And the second aspect of this is that how these software features and applications will be deployed is then dependent on the data coming from the vehicle and the data being used by either software development models, AI models, either on the edge or on the cloud, doing all this development and delivering on in the car. So, so the natural outcome of this is that there is going to be a shift. There is going to be a lot many new roles that will have to come up in the ecosystem to enable all this. How the roles get divided is probably a separate discussion because, from a technology vendor standpoint, we see that focus is on enabling this platform that the OEMs can solve for, and that's why we are focused on making sure that we don't do just the chips, but rather do the software platform, enable the so-called software developed vehicle chassis that the OEMs can work on. And I believe this will lead to a shift in the ecosystem between the traditional players, like the traditional tier ones and so on. But given that the value is now throughout the life cycle of the car, there is going to be a need for many new players in the ecosystem to operate around the data, operate around the software services, and so on. And that's what we are excited about.
Yeah, maybe to build on what Rajat was talking about. So I think it's also worthwhile to maybe step back and think about, you know, uh, there's a stratification in the market at the OEM level in terms of demands and needs from the ecosystem. So at a very high level, you can think of a bucket of OEMs that actually want to do more in this agile, dynamic, software defined world. And they want to take in that development, take in that responsibility. And there are others that, for various reasons, tend to stay on the traditional path, the ecosystem sort of constitution that Samir was talking about. So my general take is that the ecosystem is evolving. It must evolve for things like, AD and advanced levels of AD. I mean, we talked about chips and software. There's also data. There's cloud data service providers. It is a huge element for the development of the software that is then deployed on the chips in the car. So the ecosystem is evolving. It is going to add new categories, new participants, and the division lines of that ecosystem will also sort of shape out based on the preferences of the participants.
The same theme. So if you think about the vectors an auto OEM has to differentiate, those are evolving as well, right? Historically, it used to be the driving experience with more ICE engines, or it used to be it's a luxury car, it's this segment. Today, if you buy $25,000 auto from, say, China, luxury wise is pretty up there, right? I mean, they're making solid progress. And with electric motors coming in, those vectors are evolving. So when you think about both from an auto perspective, auto OEM perspective, and also from the vectors which silicon vendors have to invest, what are the top two or three things you still think 10 years from now are going to matter from a differentiation perspective? Maybe someone you start this time.
Yeah, I think there's this big push on differentiation from zonal architecture and the software-defined vehicle that we've talked about. I think what I see the transition now. I think you've all seen the Cybertruck. Some people like it, some people don't. But there's the Cybertruck today uses 48 volt technology. It is really bleeding edge on the 48 volts. I mean, you're all used to a traditional 12 volt battery, but the Cybertruck is really using that. It's also using a steer-by-wire as well. So I think they're really pushing, the Cybertruck has really pushed the envelope there on 48 volts, which really reduces the weight of the car as well. As you think about OEMs in the future, they are going to a zonal architecture, and I'll explain why it's differentiated, but they're going to some sort of zonal architecture. And the zones means there are 4 zones: a left, right, center, back passenger 2 zones, and the driver, the zones in the front. And if you look at this 4 zone architecture, you can actually compartmentalize what I talked about. If you get to a corner module, you get to a lot of integration on those zones, and allows you to control a lot of those zones more effectively. So you can do 2 things. You can make your steering and braking experience better. That's number one. And number two is, going to 48 volts or different architecture, even like a steer-by-wire architecture, you reduce the weight and you can extend, you extend the range of the car as well. So I do see a lot of that. And I'll let Rajat talk about some of the other advantages on the software-defined side.
Absolutely. And I'll give two. I'll probably split it in 2 parts. So first one is differentiation in hardware or hardware architectures, where I think Suman touched on zonal architectures. So we try to question what does zonal architecture mean, and from our perspective, I think what's driving it is centralization of data, because as the experiences, the software-defined vehicle vision has to be realized. Software-defined vehicle essentially means that software has to evolve and drive these experiences, and software has to control these experiences. Software can only do that if there is sufficient data available on the central compute to be able to build the software and then control the control modules. So, from a hardware perspective, what we see us doing is ensure that we are building the right architecture at silicon to scale for zonal compute. Example of that is a recent launch we did in Qualcomm, what we called as the Flex SoC, and this was pretty interesting and actually very widely. I wouldn't say that we saw that this was attractive to a lot of OEMs, because in past the compute modules for different parts of the computations, whether it is cockpit, as in the displays and the infotainment, or ADAS, was different chips and different size of chips. The thought process of Flex SoC was that we see everything to be about a central compute, and then software to define whether it wants to use it for infotainment or an entertainment feature using the GPUs, or using the same IPs such as the GPU, CPU, and the AI accelerators to do autonomy. So the step one in our what we launched was these Flex SoCs designed for zonal compute, thus bringing everything possible from having media, infotainment, ADAS, and to some extent body controllers in one chip, and let the OEMs decide how many number of chips do they want to scale with. For entry tier vehicles, probably one chip, but higher tier you can scale with multiple chips. The second part of differentiation enablement from our perspective is again going back to all about software. So now you solved for the zonal compute and you got the chips and you got all the data. How do we define both tool chains that can take this data and then enable a developer ecosystem to go develop the AI models and develop apps on that? So that's one area where we find that there is a clear trend going towards the software defined vehicles on enabling this developer community on a vehicle. And lastly, from a software point of view, we also see that there is a need to change the way the business models are constructed on between suppliers such as Qualcomm and the OEMs. For instance, in past it was the business and sourcing was defined in a point in time where the requirements are known on day one, and you buy that, you deploy that, and that's it. Now, if software defined vehicle and a continuously evolving vehicle has to be real, then the model of this has to also change, because requirements, you don't know the requirements on day one. So how do you plan for changing requirements, changing performance of the chip on a continuous basis or a need basis in the car. And that's something that we are working on. We are actually making it possible with some of the technologies we develop in Qualcomm.
Okay, so at NEO, we have this thing that we refer to often. We say that trillion operations per second tops are the new horsepower. Okay, so that is a given. That is a world we have already arrived in. On top of that, this notion of software-defined vehicles, super important, because at the end of the day, right, when you think about the benefit for the user, right, like Rajat has a vehicle, what does he really want from it? He wants the vehicle to keep on improving. And to be able to do that, a architecture underneath that he's oblivious to, he doesn't care about, but the architecture underneath needs to be flexible enough to connect, to download, to deploy, to reallocate, and to keep on evolving. So the benefits, I think the original question was about, hey, what are sort of some of the advantages and benefits of, let's say, SDVs at the user level, at the consumer level, at the Rajat level? Uh, I think certainly continuous upgradability and evolution of the end product is an amazing advantage. Um, at the OEM level, there's a simplification of the post sales process, right? It's amazing. I mean, you look at many of these recalls these days, uh, and they are resolved. Oh, like a few 100,000 vehicles impacted, and they are resolved the next day through a software update. That's beautiful. That's a great artifact of a software defined vehicle, and the ability to sort of harness the advantage over there. I would also say there's kind of obviously an inherent cost advantage to the OEMs, but there's a business model implication also, because things can evolve, because software can and will evolve. Now you have the ability to think about, okay, how do I package this, right? Like you were talking about new things coming up and software getting updated. You can have subscriptions on the car, so opens up a lot of things. I think the frontier is very, very open and very bright.
So let's wake up the audience, right? How many of you have actually stripped down your car down to the wire? Raise your hand if you have done it. Whoa, there's a few people. I wasn't expecting any. Well, please don't try this at home if you haven't. A car today is an extremely complex device, but complex not equal to advantage. So advanced, right? There's boxes everywhere. We're stuffing them everywhere we can, and there's cables going everywhere as well. And the weight of all of them and the complexity of all of them adds up, and that takes away from the range. All these equations just they're more destroying each other rather than adding to each other. Um, the whole goal of SDV, zonal architecture, all these things is to simplify. And in this particular case, the simplification equals making it more advanced. So focus more, reduce the number of hardware components, consolidate the hardware components into one computer if possible, and as few, one majorly smart computer and a lot of peripherals is what I would say, instead of so many computers in a car. And everything being driven by software, which means the advantage is software can keep evolving and we can keep making your car better and better over a long time. That's the beauty of this. So complex not equals advanced, and simplification equals advanced is where we're going, and everything being done from, weirdly enough, I'm responsible for hardware product management at my company. My job, if I'm very, very successful, is to make my job obsolete, reduce the role of hardware in the car, and increase the role of software in the car and make it very, very simplified. I brought a quick prop here. I'm walking around with two phones. One of the perks of my company, one is my personal phone, another one is for work. But if you look at it, the two companies that make these two phones, they hate each other. They're competing with each other for business. But 80% of the hardware and software on those two phones is exactly the same. Comes from just a few suppliers, right? That's where we are all looking to see cars go. It pretty much, if you strip down two different automakers' cars, they are very different today. But we'll see that simplification, we'll see that consolidation, and it'll all become much more uniform. And that's going to be a beautiful world from a hardware perspective and a software perspective. You may not see it as the end user from the hardware, but you will see it come up in the user experience.
Excellent. So let's double click on the business model. So if you go back in just over the past 15 years or so, as the internet exploded, there were some companies who came out as winners, and there's some companies who, while grew, did not necessarily capitalize on the situation. If you think about our operators, AT&T, Verizon, if you think about Nokia, Ericsson, most of the internet runs on their backbone. Yet their valuations are nowhere close to the Instagrams and the Metas and Apples and this. So what, as this dynamic on the auto changes and the hardware starts getting standardized, which I completely agree with, and software becomes, there are more transactions on that. How do you guys see this playing out on the ecosystem? What do you need to be aware of to not end up on the wrong side of this discussion, either as silicon vendors or as auto manufacturers?
Yeah, maybe I'll kick it off, right? So, gross simplification, but we as OEMs, the auto manufacturers, need to be super in tune with what the end user's preferences today are, right? And we also need to be super in tune with the sort of stratification, the generational stratification of those end users. What is the entry stack into that usership cohort looking like? What are their behaviors? What are their preferences? Because they will be the users of the future. So maybe to simplify, right? That's the starting point. That's the observation point. And if those users are in their in their phone worlds are behaving a certain way, have a certain set of expectations and business models that come very naturally to them, the rest of their lives actually need to be supported by similar approaches and business models. So I would say that's a starting point.
Again, I mean, most of what I say is my personal opinion, not necessarily that of my company, with that caveat. So let's say, there used to be a time, again, I go back to the phone world, my analogies are mostly from the phone world. There were companies that used to be in their phones were in everybody's hands. Everybody remembers Nokia, Motorola, maybe I'm dating myself a little bit, but those were companies that could manufacture absolutely amazing phones at a very low cost that are very usable. But then the world changed. The users came to expect more and more features, more applications, better experiences, and better ecosystem connect. I want to build more loyalty to a particular ecosystem, the Apple ecosystem or the Samsung ecosystem. That is coming to the vehicles as well. It's not just going to be about how my vehicle drives or how the infotainment system works or how the radio works. It's going to be about how do I feel connected to my vehicle and how does my vehicle enable me to be connected to the world outside of it, and how much am I able to not physically mobile, but also virtually mobile. How am I able to run my life while I'm sitting in that traffic in LA, right? Most of us know that. So it's all about the ecosystem. What we saw happen in the phone world and in the PC world and the Mac world and so on is going to come to vehicles as well. So it's all about focusing. Again, the focus is on software and building that ecosystem and building that community around all the services and features we provide you in the vehicle.
See, what I believe is the focus has to start from what is the value to the user, because ultimately it's all about the user. OEMs design the vehicles for the user. We design the chips, software, technology for the OEMs, again for the user. So if we keep, while designing these systems, if we keep the focus on the design and also the business model, focused on how we are delivering, whether it is a hardware feature or a performance, and associate to the value to the user. I think that's what will be needed to participate in the economy of this future of autonomy. The second point is that I think all this has to happen in partnership. Partnership in this ecosystem is extremely important. I don't think that any of these models can be done in isolation by one party here. So we all win together, and if we keep the user as a user and this evolution of features, software-defined vehicle in the center, I think we win together.
I think maybe Saurabh can say about the changing business models. I think today your batteries are a service, right? It's
That is correct.
you actually buy the car, but you lease the batteries at Neo. Now, I do think that silicon vendors need to start to look at, in the future. I think the car is just like SaaS. I mean, it'll be a CaaS, the car as a service over time, where it's just the like he's talked about the ecosystems changing. There's other people who are going to make money on the subscription to a car, and maybe it becomes a subscription from AT&T that you buy the car from. We get as far fetched as there. But I think the batteries as a service, that model, I mean, that means we as a silicon company need to really evolve on the software side and make sure our interfaces, the software interfaces, are getting much easier for our OEMs to manage as well.
As we get towards the end of this discussion, right, I want to bring the focus back to innovation and AI. But as you give your closing thoughts, the question I have is, if you look at the data center ecosystem, where ChatGPT has happened, many other AI innovations are starting to permeate our day-to-day life at a pretty rapid pace. And then you compare that to the automotive industry, where we've been talking about ADAS going to autonomy for a very long time, but we are, while making progress, are slow. So, just as we wrap up, your closing thoughts on what can the automotive industry learn or get inspiration from other industries, including the data center, to accelerate the pace of innovation. Just and maybe Rajat, you start.
I think there is a lot of parallels that we can derive. Like, one of the things that data centers have led the industry and kind of changed the way we all develop is how data centers have aggregated the data, scaled the availability of data from anywhere in the globe. Another aspect, how data centers have made compute limitless. You can scale the compute. Don't need to worry about whether you're running on one chip, two chip, and number of chips. And to do both of these, to do the data and the compute, how data centers have evolved the backbone of the connectivity itself, high speed connectivity to data. Now, the parallels on what is in a car are very similar. Like if you go back, I don't know, 10 years to where we want to be in 10 years from now, the data has scaled, the data within the car has scaled probably more than 1,000 times with more sensors and more sensors, each sensor producing more amount of data. And all this data then has to be aggregated, has to be processed, and some of that processing will be done locally. Some of the processing may require some queries going back to the cloud. So I believe that learning from the data centers and the cloud on the benefits of this data aggregation, compute aggregation, can be applied on the edge, all the way from silicon architectures and silicon themselves on how do we enable silicons or compute to scale from one chip to multi-chip, to also connectivity and backbone inside the car. And I think we talked about software a lot. I'll refer to one of the examples that Nakul talked about in the keynote in the morning, where one of the demonstrations we did on Snapdragon concept vehicle was the user being able to now press a button and ask the car, hey, what's in the front? And we did it in Vegas, so you can say, hey, this is a hotel. Okay, book me a room, or write me a story. Many of these queries are running on the data center or the compute inside the car, and some of them are going to the partner, which is cloud, outside the car. And that's how I see this future evolve.
Um, Maybe I'll. So, what do we learn from these companies? We talked a little bit about business model, but that really pops for me because that is starting to become established reality, right? Just like AWS came around because Amazon had a need, they developed systems and ways of servicing their own internal needs, which became so solid and valuable. They said, "Hey, we can democratize this. We can bring this forward." I feel it's sort of a combination or build out of that, right? So in our battery as a service model, it's something similar. Neo has developed something. that initially was pioneered and scaled out and established and evolved by NIO itself. But now we are at a stage where we feel, hey, this is a good thing, not just for our users, for the industry. Let's democratize it, right? Let's bring it forward. So maybe something at the intersection of this, as a service model democratization, as well as open sourcing. I think there's more collaborative opportunities. Maybe we can learn from the cloud folks on.
Okay, so the auto industry used to design their vehicles like Las Vegas. What happens inside your car stays inside your car, right? And that is the biggest lesson we learned today from the data center world. Connectivity, seamless connectivity, just basically makes it's a uniform compute. You don't have to worry about hardware differences. You don't have to worry about where your job is going to run. It could be here or it could be 10,000 miles from here. Cars had to really deal with, okay, how much compute do I need to put in here? How much power do I need to have in here? We're moving into this world of, with seamless connectivity and broader connectivity pipes, we have this big infinite amount of compute sitting out there on the cloud. So I don't have to worry about whether I have enough compute in the vehicle or not. If I design my hardware well enough, the fleet of cars can act as distributed computers, and the overall cloud becomes a major extension of the compute inside my vehicle. That's a beautiful engineering challenge, and that's a beautiful enhancement of user experience we're going to see over the next few years. And that's the biggest takeaway. That's the lesson that I learned from the data center world. Once you have a broad pipe of connectivity and the cost of the data connectivity is that low, it's literally infinite in terms of how much compute and how much experience you can deliver to your vehicle. And I'm excited to see that future come into our vehicles.
I think ubiquitous compute that the teams talked about is really critical to kind of see this. But I also see that the speed at which, for example, car companies in China move are just tremendous. I've been counting cars in China, and the last time I counted, it was 3 out of 5 cars in China today are really moving towards EV. And the technology that China is in the cars is moving at a rapid pace, very, very fast, very furious. I think we as a company, we need to embrace what we call internally as China speed, the speed at which we make decisions, the speed at which companies kind of embrace the future. I think that we have to move a lot faster than where we are today to kind of see this move forward.
And so, my closing thoughts. So, first of all, thank you. See, technologies which touch most humans on the planet have the ability of unleashing unlimited value. We've seen that from data centers and internet. I think automotive is one other technology like that, which touches everyone. And I think as we accelerate towards autonomy, I think the value creation which lies ahead of us is probably very, very exciting. And thank you for your thoughts on that. And I hope the audience got to learn. I learned a lot. Thank you so much.